we've done GCF. Everything still starts with finding a GCF. We've done 4-term grouping. We've done 3 terms by guess and check and by splitting the middle term. And now we're going to go into 2 terms, but before we do that, we're going to do a couple special cases of 3-term polynomials. Special things to look out for that's going to be crucial for us as we get into a couple other skills throughout the year. So still sticking with trinomials, I want to talk about special trinomials and how to know that they're special. So what got kind of hole punched out here is the word perfect. Perfect square trinomials. What's a perfect square number? What makes something a perfect square number? Lydia? Right, so if you have a perfect square number like 25, it's because something times itself gives you 25, right? 5 times itself gives you 25. A perfect square trinomial is similar, except for some binomial times itself is going to give us that trinomial. So if we were to do this kind of the guess and check way, because it's not overly difficult, the only thing that gives us x squared is x and x. For 9, we could use 1 and 9 or 3 and 3. Based on the fact that the middle term is 6, what does your gut tell you? 1 and 9 or 3 and 3? 3 and 3. And because it's a positive 9, it either has to be plus 3 or minus 3 minus 3. Look at your middle sign. It's a plus, which means it's a plus plus. So the reason this trinomial is called a perfect square is because something times itself is giving me that. Do we follow? Okay? X plus 3 times itself, in other words, squared, would be the more condensed, efficient way of writing that. You would write your final answer like this. Now, without going through the guess and check process, what features of the trinomial should we be looking for to see that this is possible? Okay, here's the story. If your first term is a perfect square, does everyone agree that that's a perfect square? Yeah, what's its square root? X. If your last term is a perfect square, what's the square root of 9? 3. And when you multiply those together, x times 3 is 3x, right? If the middle term is double that, is 6x double 3x? Yes, then it's a perfect square trinomial. And those square roots make the binomial. Okay? So write these 2 here. These are the special patterns we're going to look for, and I'm going to explain them in a minute. Can you give me your homework, please? Because yours is the only one left on the table. I'm just going to omit it first of all. We already did it one over. You're good. Thank you. Okay, so this is the general format of what makes something a perfect square trinomial. This is a perfect square with a square root of what? X. This is a perfect square with a square root of y. And when you multiply x times y, you get xy. And the middle term is double that. Okay? And when that's the case, and this is a plus 2xy, the square root of that was x. The square root of that was y. The middle sign is a plus, and so that is going to factor into x plus y squared. Does that make sense? This one is exactly the same, just with a minus sign. So this one is going to factor into x minus y squared. So when we get to something like the second example, in which guessing and checking could be a nightmare, right? If you realize your first term, thanks Fred. If you realize your first term is a perfect square, what's the square root of that, Andrew? 5x. And if you realize your last term is a perfect square, what's the square root of that, Connor? 6. Now when you multiply 5x and 6, what do you get? 30x. Is the middle term double that? Yes. It's give or take the minus sign. Okay? The minus sign is, whether it's plus or minus, is just going to kind of equate to whether we use a plus or we use a minus. But 60 is double 30. Yes? So that the pattern is there. And that now that we know that the pattern's there, because that's a minus, that's just going to go down there. And that's going to be 5x minus 6 times 5x minus 6. Do we see that? Okay? If you wanted to sort of check it based on the kind of guess and check method, you could look. First times first does give us 25x squared. Your outer gives you negative 30x. Your inner gives you another negative 30x. That's kind of why that middle one ends up being double. And then your last times your last gives you positive 36. Does this make sense? Okay? So I added these two, and I want you to do the same. Write those in on your notes, where we're going to find the term that's missing that would make these perfect square trinomials. Raise your hand if you take a minute to think about it and tell me what that middle term would have to be. That was quick for you three. I'm impressed. 4. I think more of you can get it. Let's take a little more time. What would that middle term have to be in order to be a perfect square trinomial? Grace, what do you think? 10x. Does anyone think anything different? Cameron, how'd you get 10x, or how did you get 10x? Well, you kind of technically find the square root of both, right? The square root of this is x, the square root of that is 5, so 5x, and then you double it, 10x, okay? Technically, this middle term could have been plus 10x or minus 10x. But now that it is positive 10x, what does this factor into? Evan? Perfect. Good job. X plus 5 times x plus 5. And again, if you want to expand it out and foil it and show yourself that x times x is x squared, 5 times 5 is 25, your outer will give you 5x, your inner will give you another 5x, gives you the 10x. Okay? And then this one, what's the missing last term? Same crew. Oh, it's gotten better on this one, though. Haley Smith, what do you think? Positive 16. Raise your hand if you got something different. Good. Because this has a square root of x, and whatever this one's square root is, when you double it, you want it to be 8. So before you doubled it to get 8, what was it? What doubles to get 8? 4. So it needs to be the number that has a square root of 4, which is indeed 16. Okay? So you would take half of this, which is 4, and square it, and that's what that is. Yes? Okay, and that skill you did last year, didn't you? That's completing the square on a circle. You remember when you take half of the b term? You take half of negative 8, it's negative 4. and you square negative 4, and that tells you plus 16. You add 16 to both sides. That's how you kind of completed the square with a circle, and we'll be doing more of that this year. So just to expand on that, out of curiosity, what does this factor into? Kaylee M. Perfect. Good. All right, any questions? This next one should be a review. The difference of perfect squares factors into, here's the general rule, x squared. If you have two perfect squares and the difference between them, it factors into, who knows? Who remembers? Oh? X minus y, x plus y. Do you remember that? What are those called? These are blanks of each other. Not inverse. Not reciprocals. Reciprocals, flip numerator, denominator. Inverses, different total category, but I know why you're saying that, because you're just seeing the opposite sign in the middle. Starts with the letter C. O, N, J, U, G, A, T, E, S. Conjugates? Did I spell it wrong? It does look weird to me. Conjugates, you're going to have to know that vocab word. We're going to use it a ton this year. Okay. Yeah, conjugates looks better there in lowercase. Maybe it was my uppercase. Yeah, raise your hand if you've never heard of that word. Wow. Okay. Did you factor stuff like this? Who'd you have as an Algebra 1 teacher? So all across the board. Raise your hand if you have heard of this word. Okay. Maybe you just forgot about it. I think they've used it. They had to have used it. They probably used it in passing and they didn't stress it as being important. Yes, they did. Stop. Okay. We're going to talk about it a lot. It's going to come up and you're going to need to use the conjugate in a lot of different situations outside of factoring. But the first place we see conjugates is in factoring. And what it is just the same binomial with a flipped sign in the middle. So x minus y, x plus y, those are said to be conjugates of each other. So when you see the difference of a perfect square and a perfect square, it's always going to factor into conjugates of each other made out of the square roots. So what's the square root of x squared? What's the square root of 4? 2. So it's going to factor into x plus 2 and x minus 2. And I'll say this again and again this year. Here's the beauty of conjugates. If I'm checking the foiling, first times first gives me the x squared. Last times last gives me my negative 4. The beauty of conjugates, and the reason it's going to be so beneficial to us later in the year, is because your outer term, negative 2x, and your inner term, positive 2x, will always cancel. Right? If you were ever foiling that out. Okay? And that's the beauty of conjugates. That's why we have no middle term. That's why this is not a trinomial and it's only a binomial. Does this make sense? Okay? What's the square root of 81x squared? 9x. What's the square root of 1? 1. So 9x plus 1, 9x minus 1. Good? What's the square root of x to the 4th? X squared, square root of 81, 9. So what are the two conjugates? Both. Good. Now this one, I'm going to put a little asterisk next to, because we're not done. Raise your hand when you can tell me why we're not done. Go ahead, Fred. not always. One of those x squareds is going to stay, one of them is going to go. But I want someone to tell me why one has to go. Nate? Couldn't have said it better myself. This binomial is still the difference of perfect squares. Yes? What's the square root of x squared? X and the square root of 9. 3. So x plus 3, x minus 3. That particular portion factors further, and then we still have the factor x squared plus 9. You just have to have your antennas out looking for something like that, because that is not uncommon. We'll get to more examples that you think you're done factoring and like, oops, this piece is actually still factorable. You go further. Nate? Correct. Difference. Correct. Yep. This would be the sum of perfect squares, and that's prime, meaning there are no factors beyond. Good question. Okay? Now, this next one is going to be brand spanking new to you, and this is perfect cubes. And here, the sum works or the difference works, versus here only the difference of perfect squares works. Okay? So, the perfect cubes factoring rule is a little bit different. A little bit, definitely not a little bit, more complicated. A rule that you have to memorize that's more complicated than the conjugates. So if you have the sum of perfect cubes, x cubed plus a y cubed, it factors into a binomial times a trinomial. So first I'm going to set that up. A binomial, 2 terms, times a trinomial. Okay? The binomial is going to be easiest to come up with because it comes from the cubed root and the cubed root. So what's the cubed root of x cubed? What multiplies by itself 3 times to give you x to the third power? X. What multiplies by itself 3 times to give you y to the third power? Y. And if that's a plus, that's a plus. Now getting to the trinomial takes a little bit more of the memorization. To get the first term of the trinomial, you just square this x. Whatever that term is, you square it, so x squared. To get the last term of the trinomial, you just square that second term, so y squared. The middle term is going to come from multiplying those two together. So x times y, xy, and just flipping the sign. So if that's a plus, the middle term would be minus. You do not double it here. Okay, so part of what I find happens to be the confusion is knowing in the perfect square trinomial case that middle term is doubled. Whereas here that middle term is not doubled. So keep that straight. Now, once you know one of these, the sum that we just did, the difference is pretty much the same thing, where you take the cubed root x and the cubed root y, but because it's the difference, the binomial is the difference. Your trinomial is going to be exactly the same, except for the sign of the middle term. So still an x squared. Instead of minus xy, it's going to be plus xy, and still a plus y squared. Okay? So these two signs always have to be the reverse of each other. So if it starts out as the sum, it's the sum and then the difference. If it starts out as the difference with the minus sign right here, then it becomes a plus over here. Okay? So you have to memorize those rules. Capiche? Okay? So let's put it into action. This is the sum. Set up your binomial times your trinomial. What's the cubed root of x cubed? X. What's the cubed root of 8? What multiplies by itself 3 times to give you 8, McKenna? 2. And what sign do you want to use, McKenna? Plus, because it started off as plus. Now, jumping to my trinomial, Micah, what's the first term? X squared. Jordan, what's the last term, do you think? Not 1. So who thinks they know what it is? Cameron? 4. You take this, so Micah took this and squared it for the first term. You take this and square it for the last term, so plus 4. Who wants to take a stab at the middle term? Fred? Perfect. Negative 2x. That came from multiplying x times 2 and opposite sign. And we're done. Good? Next example. Gets a little beefed up, right? Set up your binomial, trinomial. Look at your first term. 64x to the 6th. What times itself 3 times gives you the 64? Nate? 4 is the answer to my question. But yes, you're right. And then what times itself 3 times gives you x to the 6th? In other words, what is it that you would cube to get x to the 6th? Right? A little bit of exponent rules here. X squared is the answer because power to power multiplies, right? So that's 4x squared is your first term. What sign should we use? Jake. Minus. And what cube gives us 125? Madeline. What times itself 3 times gives us 125? 15 times 15 times 15? 5 times 5 times 5? Bingo. Good. 5. That's the hard part in these. And then jumping to the trinomial, what is 4x squared when you square it? Nathan H. 4x squared when I square it. Perfect. You definitely have to slow down with these bigger ones. Negative 5 when you square it for the last term is obviously plus 25. And what is your middle term, do you think? Take a second. Pearson? Not quite. Who can help her out? Andrew, and tell her how you get it. Perfect. Multiply these together, which is 20x squared, and because that was a minus, we use a plus. 20x squared. Beautiful. Okay? Last one. The plot thickens because this first term just got a little bit crazier. It is a perfect cube. Maybe you want to look at it but like piece by piece by piece, the number, the x, the y. But what is the cubed root of 27x cubed y cubed? Amazing. Nine xy. 9 times 9 times 9. Too big. 3xy. How about our second term there? Can we all agree that 1 is a perfect cube? What multiplies by itself 3 times to give us 1? 1. And what sign should we use in the binomial? Minus. Good. On your own, come up with the trinomial. And whose lovely voice haven't I heard yet today? Anybody? Aiden? What's the first term of the trinomial? Perfect. Do you have the middle term? Do you have the last term? Nope, we take this one and we square it. So what is that? Just one, right. Our middle term, who can do that? Zach? Positive 3xy. If this is a minus, this has to be a plus. Okay? That's going to definitely take some practice. It's a thicker kind of rule to remember. Homework is still coming from the same worksheet. Your spiral is going to come out in a minute. Really quickly, though, let's review the week, because we've got a few new flashcards to add, and I'll scan in this updated version. Average rate of change, your slope formula. Point slope format for writing the equation of a line. You have to know that. Point slope format, so you plug in your point, x1, y1, and your slope. If I'm going through systems in 3 variables, there's not really a flashcard for that. Today we came up with a slew of flashcards. If you see this on the front of a flashcard, you are going to put this, x plus y, x minus y. Yes? If you see the difference of perfect cubes, you need to know this rule, x minus y, x squared plus xy plus y squared. And if you see the sum of perfect cubes, same thing, x plus y, x squared minus xy plus y squared. Pretty much the same thing. And if you see a perfect square trinomial, what number are we up to? 23? Here's how I'm going to write the perfect square trinomial one. I'm going to do x squared plus or minus 2xy plus y squared. Okay, and if you see that format, it turns into x plus or minus y squared. If it's a plus, you use a plus. If it was a minus 2xy, you use a minus. Does that make sense? Okay, so we're gonna add those flashcards to the mix. Okie doke. You need your just a heads up there.